How are you guys? Welcome back to my YouTube channel. Today we're dealing with mathematics N5. Let us deal with integrating. We'll integrate by inspection. We'll deal how can we integrate or evaluate. How can we integrate this by inspection? The rule of inspection, you must know that if you're given the integral of f of x, right? F of x raised to the n multiplied by f of x prime, right? You must apply this formula, right? Dx is equal to, take this will be f of x, right? Use the power rule, divide by n plus 1 plus constant c. We'll apply this formula. What does this formula? How can you apply this formula? That means you check if you have a bracket, you have a power, you have an exponent, what is inside the bracket, if you differentiate it, right, must give you the corresponding, must be equal to the product, must equal to the derivative of the product, right? In other words, if you're given, if I take a derivative of this, must give me this derivative. The derivative of what is inside must be what I multiply with. For an example, let us solve this one. How can we solve that one? We'll apply this formula. Solve that number 1 here. Then as we solve that, we have the integral of 3 squared into x cubed plus 5 raised to power 9 dx, right? Want to apply, let us apply this formula there. We apply the formula then. So what will be the f of x? You can rearrange this. You see, this will represent what? Exponents. Here it is exponents. You can say here our n here. What is our n here? It's 9, right? What is f of x? F of x is this one. F of x must be equal to 3, must be equal to x cubed plus 5, right? Then what about f prime? You take f prime, well, you drop the exponents, will be 3, subtract 1 will be 2, this will be 0, right? We will have this is we have f prime. So let us check this f prime. There is a corresponding, if you can check here, if this scenario happened like this, if you can check the integral of the f of x, what is inside, it's an integral, it's a derivative of this product. So you can use an inspection. If this happen, you see this is the same as this. If you differentiate this, you will get this. If you differentiate what is inside the bracket, will give you this, the what you multiply with. Then you can apply the inspection formula. Then let us apply the inspection formula. Inspection formula says you'll write f will be, you'll use this formula, right? Will be f of x. Here it's our f of x, right? Will be equal to f of x. Here it's our f of x is x cubed plus 5 plus 5, right? But raised to the certain exponents, you know n. What is our n? Is 9. We add what? 1 over 9 plus 1, right? Plus the constant c. If you simplify this further, you will have x cubed plus 5 is 10 over 10 plus c. This is the answer, right? We use inspection. It's how we apply inspection method, right? Let us try another problem again. Say number 2, we can integrate into 2x raised to the power 5 minus 3 raised power 6 dx, right? Let us try applying the inspection. We know this. If we differentiate this, must give us what we multiply with. So let us apply the formula. We know the formula. We know our formula is f of when you integrate, right, f of x this must be equal to f of x n plus 1 over n plus 1 plus constant c, right? To apply this formula, let's check there. Check this, that let's make n is what? N will be equal to 6. What about this? Will be f of x. F of x is this. What is inside the parentheses will be equal to 2x to the raised power 5 minus 3. You want now to take prime, f prime. You multiply, this will be 10. You drop the exponents. You minus subtract 1 will be 4. This will be what is 0. You have this. You have 10 x to the power 4, but here we have x to the power 4. You see, but our formula suppose this to correspond. When you differentiate, this must be the same with this one, right? That means when you differentiate, f of x must be the same as f prime when you differentiate. So you see, f prime is not the same as this one. These things are not the same, but let us adjust. You have 10 here, we don't have 10, the coefficient. Let us adjust. When you adjust, we can multiply. We can say we want this to become, we'll say 10 divided by 10. 10 divided by 10 is same as what? This 1. We did nothing there. Then you will introduce, will be integral x 4 to x power 5 minus 3 with 6 dx, right? Take this 10. Then when you take that, when you multiply by that 10, you'll have 1 over 10. Integral will be 10, right, to x raised power 5 minus 3 all over Right, now we have this. Now you see 10, our f prime here. This derivative will expand, they correspond. We have this, which is the same as this, right? Now we apply this formula, right? We apply the inspection, we apply that formula. The formula, we take this, here it's a formula, we apply the formula. F of x, we know the f of x is this one, right? Now this will be equal to, take this will be 2 x raised to the power 5, right? N is 6, which is 6, we add 1, we divide by the whole of this, will be 6 plus 1, we add the constant c, and then this will be equal to 2x raised to the power 5 minus 3, 7 over 7 plus c. This is how you apply the inspection formula, right? Integrate by inspection, right? Let us try. Problem 3. We have the integral of 12 raised to the power 2 plus 10 all over square root 2, 3 plus 5 minus 7 dx. Let us integrate this. There are many ways you can integrate this. You can apply whatever, but now we're focusing on inspection, right? Let us integrate by inspection. Okay, now just rewrite this. Will be 12 plus 10, take this on the top, you take this on the top, right? Will be you put a bracket, will be 2x cubed plus 5x minus 7 will be minus 1 over 2, right, dx, right? Now let us make this will be f of x, right? F of x will be equal to 2x cubed plus 5x minus 7. Then we differentiate this, drop the exponents, will be 6, then x subtract 1 is 2 plus 5, right? So we apply the formula, this and this, they are mainly not the same, but let us try to make this to be equal to be the same as this. Okay, then we know you can write, you take out the common factor here, you can divide this common factor is what is 2, you can take 2 outside, you'll be left with be 6 squared plus 10, right? Plus 10, multiply all of these, let me say 6x squared plus 5, multiply all these plus 5 minus 7 raised to the negative 1 over 2, right? Right, now let us apply the formula. We know I've shown the formula. Since we know the formula now, we know our n is equal to minus 1 over 2. F of x is here. We have n, then we can apply the formula. You know the formula. Then this will be equal, will be 2. Right. All over will be 2, 3 plus 5 minus 7 minus 1 over 2 plus 1 over minus 1 over 2 plus 1 plus constant c. Right. If you simplify this further, this will be positive 1 over 2, obviously. This and this will have what? Positive 1 over 2, positive 1 over 2. Then this will be the same. Let me distribute the 2. There will be 2 cubed plus 5x minus 7 1 over 2 all over 1 over 2 plus the constant c. If you want to simplify further, let us simplify this further. If we simplify that further, this will give us, we multiply here by 2 over 1. Also we'll multiply the top by 2 over 1. This and this will cancel. Then we'll have 4. 2 multiplied by this will be 4, right? Here will cancel, we left with nothing. Then this is the same as the square root of all that stuff. Then of all this stuff will be 2x cubed plus 5x minus 7, right, plus c. This is the final answer, the simplified answer. Okay. So problem 4, right. Problem 4, just integrate 2x plus 5x squared plus 5x raised power 10 dx. Let's apply the inspection here. Yeah, we apply the inspection. We'll let f of x, this will be, you can let this will be f of x, right, which is s squared plus 5x. Then f prime, you drop the exponents, will be 2, x you subtract 1, then that will be what, plus 5, right. This is the same as that, right. If this is the same, if we differentiate this, then this, if we differentiate what is inside the bracket, and then we found that when differentiate will be the same as what is multiplying, we will simply take only this and add it. We'll simply take this, will be equal, we take only that, will be x raised power 2 plus 5. Take this, you add 1, also divide by this, will be 10 plus 1. You add the constant c, this will be x squared plus 5x 11, this is 11 plus c. This is the final answer, right. We've integrated this is the final answer, right. Let us simplify. Let me have integral cos raised to the power 5x multiplied by sin x dx. Let us integrate this by inspection. We can integrate this by inspection. Then let us figure out this. You can write this. This will be the same as cos x, right, raised to the power 5 multiplied by sin x dx, right. Let us make this to be f of x will be equal to what, cos x. Then we take the derivative of this prime x, then we know will be minus sin x, right. So there's a relationship, you see, there's a sin x, also you multiply by sin x. When you differentiate this, we get negative sin x, but here there's a positive sin x. How can we make this to be negative? How can we make this to be negative? Negative sign, but not changing the entirely equation, and not changing the format. You can multiply by what? You can write this, you can say, you can multiply by minus 1 over minus 1, because this is the same as 1. We did not change anything here. See, integral cos x, right, raised to the power 5 multiplied by sin x dx, right. Then can multiply, we can take the negative that side, then we'll be left with negative 1 integral. Then you can rearrange this, the order doesn't matter. We'll have will be, when you multiply, there will be cos 5x minus 5 minus sin x. So now we have this, which is the same as this. So we apply the inspection formula. The inspection formula, we know we'll have f of x, we know the integral of f of x, right, raised to the minus, raised to the power, multiplied by f of x prime must be equal to what? To this, to the f of x raised to the power n. You add 1, you divide by n plus 1 plus c. We use this formula. Our f of x is cos. Here, use that formula there. F of x will be what we said is cos, will be cos x, what upload n. N here, you see n is 5. N is equal to 5. N is equal to 5. You can come here. We'll have 5 plus 1 over 5 plus 1 plus constant c. Right, then simplify this further. When we simplify further, we'll have cos x raised will be 6 divided by 6. Then this you can just put there and will be 6 over 6 plus c. This is our answer. Right, this is the first technique that you can apply. This is the first technique that you can apply. Let's try another problem.